Hello everyone, welcome to the video on IPv6 addressing, structure and types. In this video, we will understand what IPv6 is, its structure, different types of IPv6 addresses and why it's important for the future of networking. So let's get started. We will see why IPv6 was introduced. We know that IPv4 uses 32-bit address, which means it can support around 4.3 billion unique addresses. But with the rapid growth of internet, this number is no longer sufficient. Thus, to solve this issue, we have IPv6 introduced, the latest version of Internet Protocol. IPv6 uses 128-bit address, providing an enormous number of addresses. And apart from providing more addresses, IPv6 also enhances security, improves routing, and simplifies network management. Now let's take a closer look at how IPv6 addresses are structured. IPv6 addresses are 128-bit long and are written in hexadecimal format. They are divided into 8 groups, separated by colons. Each group consists of 4 hexadecimal digits. Here on the screen we can see an example of the address. Since these addresses are quite long, we can simplify them using zero compression. Any continuous block of zeros can be replaced by double colons. However, this can be done only once in an address. So, in our example, the compression will look like this. This makes it easier to read and use. And now that we understand the structure, let's move on to the different types of IPv6 addresses. IPv6 addresses are categorized into 3 main types, each serving a specific purpose. First one is unicast addresses, used for one-to-one communication, where a packet is sent to a specific device. It is found in everyday internet communication such as accessing websites, email services, and direct device-to-device communication. Second one is multicasting. It is used for one-to-many communication where a packet is sent to multiple devices that belong to a multicast group. It is commonly used in streaming video conferencing and real-time applications where the same data uh, needs to reach multiple recipients efficiently. Then the last one is anycast addressing. It is assigned to multiple devices, but data is sent to the nearest device in the group. It is mostly used in load balancing, content delivery networks, and distributed DNS services, where multiple servers share the same IP address and requests are routed to the closest one. One major difference between IPv6 and IPv4 is that IPv6 does not support broadcast. In IPv4, broadcast addresses were used to send data to all devices in a network, but this was inefficient and led to unnecessary network congestion. Instead of broadcast, IPv6 relies on multicast to efficiently communicate with the multiple devices while avoiding network overhead or anycast as per the need of the network. IPv6 also includes special addresses with unique functions. First one is loopback address. It is used for testing network configurations within a device. Second one is link local address. This address is automatically assigned to devices and is used for communication within the local network, but it cannot be routed over the internet. Third one is unique local address. It works like private IP addresses in IPv4 and used for internal networking. And the last one is IPv4 mapped IPv6 address. It helps in the transition from IPv4 to IPv6 by allowing IPv4 addresses to be represented in an IPv6 format. These addresses make IPv6 more versatile and adaptable to different network environments. So why is IPv6 better than IPv4? Here are some key advantages. First one is larger address space. With 128-bit addresses, IPv6 can support an almost unlimited number of devices, making it future-proof. Then second one is better security. IPv6 comes with built-in IPsec encryption, providing enhanced data protection and authentication. Third one is no need of NAT. That is, since IPv6 provides enough addresses, devices can communicate directly without using NAT, improving efficiency. And last one is efficient routing. IPv6 simplifies routing by using hierarchical addressing, which improves network performance and scalability. To summarize, IPv6 is a revolutionary improvement over IPv4, offering a massive address space, better security, and improved efficiency. Today we learned about IPv6 addressing structure and how it differs from IPv4. The three main types of IPv6 addresses: unicast, multicast, and anycast. Why IPv6 does not support broadcast and how multicast or anycast replaces it. Then special IPv6 addresses and their purposes. The advantage of IPv6 over IPv4. As the internet continues to grow, IPv6 adoption is increasing, and it's crucial for organizations and individuals to transition to IPv6. So that's all for today. Thank you.